Hello students, today a very important day, that is we are celebrating the Gandhi Jayanti, birthday of father of our nation, great leader, great lawyer, philosopher, great we can say freedom fighter. So on this occasion, in this important day, wish you happy Gandhi Jayanti. We have to follow the principle of the great man who has tremendous contribution for the nation. Particularly, if you see the independence for the country, their sacrifice, their dedication, their contribution cannot be compared. Really, it is commendable for this dedication, sacrifice, selfless service for the society. So, in this important day, let us come together and obey their principles like truthfulness, non-violence, remove the barrier like untouchability, casteism from the society, and develop universal brotherhood among us. Our India wants these things because you see 300 years back, Britishers, they came to India for big trades, for business. But due to when they came to know the resources available in India, they started the exploration. They wanted to take some resources from our country. Although we have much more contribution to drive away from this country. So for this, so many freedom fighters have given their sacrifice, their life for this motherland. Let us come together, develop a spirit among us, develop the seeds of patriotism in our heart, in our mind, and love to others, serve for all, serve for the country, how we'll be happy, how all others will remain happy. This should be our motto, and we have to contribute some dedication for our development of our country. I hope this day will bring spirit of non-violence among us. We should remain peaceful. Pray God to remove this pandemic situation, coronavirus, from our country, and how will we peaceful, how will we stressless and continue our happy life to remove this virus, to stop this virus from this our motherland. Okay? So today in this class we are going to discuss the types of intermolecular force. So today in this class we are going to discuss the types of intermolecular force exist in matter. We know matter exists in generally three states: solid, liquid and gas. These three states, matter exists in three states mainly due to difference in intermolecular force. If you see, only due to intermolecular force difference results solid, liquid and gaseous forms. So what are the nature of force? First, what type of force exists between the molecules of matter? Let us discuss for this. Generally, if you see, already you have read that in chemical bond some molecules are polar, having partially positive and partially negative charge. Some molecules are completely ionic character, that we can say is ionic compounds, and some molecules is non-polar, having no charge on it. How these molecules come closer? When they come closer, what type of force exists between them? And due to this intermolecular force, how the properties of the matter changes, and which force is responsible changing the particular characteristic of the compound, let us discuss. So, on the basis of intermolecular force are different types. That is, first one is dipole-dipole force. Dipole force. This dipole-dipole force means, already you have read in covalent bond that some covalent compounds are polar nature due to difference in electronegativity of bonded atoms. So that's why partial positive, partial negative charge develop in the molecule. That's why these are called dipole molecules, that is polar molecules. So when two polar molecules come closer, then what happens? The partial positive side attract the partial negative side. This is called your dipole-dipole force or dipole-dipole interaction. Here what happens? You see a molecule. Suppose it is partial positive, this is partial negative. When another molecule comes closer, partially positive, partially negative. What happens? These two forces attract each other. Partially negative with partial positive, because both are polar nature, having partial positive charge and partial negative charge. So already you know that plus will attract minus. So what happens? This force exists between the molecules. This type of interaction between polar, it is a polar molecules. It is also a polar molecules. When both polar molecules come closer, then the attraction starts. That is called dipole-dipole interaction between two polar molecules. Attraction between two polar molecules is called dipole-dipole interaction. Example you can take, suppose HF molecules, that will be partially minus, partially plus, attract, partially plus with partially minus. This type of attraction is called what? Dipole-dipole interaction. Dipole-dipole interaction may be hydrogen. It may be a hydrogen bonding. It may be hydrogen bonding. But always hydrogen bonding, all dipole-dipole interaction is not hydrogen bonding. But hydrogen bonding, one example of dipole-dipole interaction. So, interaction between polar molecules is called dipole-dipole interaction. Similarly, liquid ammonia, for example, liquid ammonia in liquid state, it is also a dipole-dipole interaction. Water, liquid, that is also a dipole-dipole interaction, that is, you can say, it is hydrogen bonding. So, there are so many examples of dipole-dipole interaction. Then, another is ion-dipole interaction. Ion-dipole attraction of force. Ion-dipole force. Here what happens? Ionic species and polar molecules. For example, if you take sodium chloride, it has plus and minus charge. Already it has plus charge and minus charge, completely positive and negative charge in the molecule. Then what happens? This When you dissolve this sodium chloride in water, then what happens? Water is a polar molecule. Water is a polar molecule, but sodium chloride is ionic ions, it produce ions. Then there will be attraction between ions and polar molecule. For example, then what happens? Suppose you take sodium ion. Sodium ion, this sodium ion attract by water molecules. This attraction water molecule due to the positive charge with partial negative oxygen. So due to this attraction, the ions gets dissolved in solvent, particular solvent. Suppose sodium ion dissolved in water, Cl minus ion dissolved in water. That's why sodium chloride is water soluble. This interaction, solubility also attraction between the solute and solvent. Here the attraction is Na plus and water molecule, Cl minus and water molecule. Due to this attraction, the particular ions gets dissolved in water in a particular solvent. So ion-dipole interaction, ion and dipole. That means you can write like this: Na plus with water and Cl minus with water. Aqueous Na plus, aqueous Cl minus. These are the example of ion-dipole force, that is ion-dipole interaction. Here what happens? Polar molecule will attract the ions, or ions will be attracted by polar molecule. Both are attracting each other. One particular pole means either positive pole or negative pole, attract the opposite charge pole. Then ion-induced dipole. Ion-induced dipole force. Ion-induced dipole force, if you see ion-induced, here what happens? Particular ions will attract the what? Induced dipole means a polarity is developed. For example, suppose I minus means it is dissolved in water. I minus K, suppose K, I minus in aqueous medium. When you are iodine to Ki solution containing I minus, then it will be dissolved. Then iodine will be dissolved. Iodine will be dissolved in I3 minus form. This iodine will dissolve in which form? In I3 minus. So this type of interaction is called ion-induced dipole. For example, if you take I minus here, what happens? I minus with I2 molecule. This is I2. I2 means here one iodine, here one iodine. Then what happens? When I minus will come closer to I2 molecule, then partially positive, automatically partial negative charge will develop in I2 molecule. I2 is non-polar, there is no charge on I2. But when it will be remain with the I minus is a ion. And it is a what? Non-polar. But when it come closer, then polarity. I2 is non-polar, but when it present, it remain in presence of I minus, then polarity will develop in I2 molecule. One side will be partial positive, other side will be partial negative. This attraction results formation of I3 minus. So this type of attraction is called ion and induced dipole. That means force of attraction between ions and non-polar molecule. It is a force between ions plus non-polar molecule. That is called your ion-induced dipole force. Then another force is Dipole-induced dipole. Dipole-induced dipole. force. Dipole-induced dipole means what happens? Here a polar molecule or non-polar molecule in presence of polar molecule. But here last one what? Non-polar molecule in presence of ions. Here non-polar molecule in presence of what? Polar molecule. The polarity will develop. For example, if you take liquid ammonia and iodine, here soluble, I2 soluble, I2 soluble in liquid ammonia. Here what happens? This ammonia molecule creates polarity in I2. As ammonia molecule has already know, as ammonia molecule, suppose the ammonia molecule, it has one plus and let it be partial plus, partial minus side, because it is a polar molecule. Polar molecule means it has partial positive, partial negative side. When we come to the what? When we come to the non-polar molecule, this is one iodine, this is one iodine which has no charge. But when it comes closer, as one side is negative, then partially positive will be created in one side, other side will be partial negative. So this is called what? Polar and non-polar attraction. Non-polar molecule will attracted by polar molecule due to formation of polarity. That's why it is called induced dipole. I2 is non-polar. It is non-polar. But polarity is developed in presence of polar molecule. That's what is called dipole-induced dipole molecule. So I2 is soluble in liquid ammonia due to what? Dipole-induced dipole attraction. So this another important attraction is there. London force. It is called London or dispersion force. London or dispersion force. This London and dispersion force, it mainly occurs in between non-polar, in between non-polar molecule. This is important thing. How non-polar molecule is attracting one another. There is no charge possibility of charge formation. There is no charge on the non-polar molecule. But how non-polar molecule is attracting one another? Let us discuss. So this force between non-polar molecule is called London force and dispersion force. And this force is very weak force. Very weak force. Very weak force compared to other force. Very weak force between the non-polar molecule. And this polarity that attraction occurs, attraction exists due to what happens. Suppose it is non-polar molecule. It has a nucleus. Non-polar means it has the bonded atom has nucleus and the moving electron. Another molecule, another atom, same nucleus. What happens? Here, electron. Then when it will come closer, when these two atoms come closer, due to difference in movement of electron cloud, due to difference in movement of or due to difference in electron cloud in the two closely placed atom, what happens? The polarity is developed. What happens? This nucleus will attract the outermost electron of other atom. Similarly, other atom, second atom, its electron cloud attract the what happens? Attract the nucleus. So what happens? What's one side will be formation of this is plus and this is partial minus. This is partial plus will be formed. Then other also same. Partial plus, partial minus will be developed due to this attraction. So electron cloud of the first atom attracted by the what? Nucleus. So due to this polarity is developed, and this is called London force. This is called London force, or it is called dispersion force. And this force exists when the molecule is very close to each other, or atom is very close to each other. It has been observed that in case of London force or dispersion force, the energy, the attraction energy is directly proportional to R to the power 6. That means when the distance will be very low, then attraction will be more, then more energy release. When there is attraction, there is loss of energy. If attraction is very less, then energy will be much more energy release. That means attraction energy, intermolecular attraction energy is inversely proportional to what? 6th power of distance. That means if the distance become double, if distance is double, if distance will be double, then energy decrease. How much? Decrease energy will be how much? 2 to the power 6, that is 64 times energy will be decreased. What means? The amount of energy decrease will be less. 64 times will be less if distance is double. If distance will be more, then less amount of energy released. So the intermolecular attraction energy is inversely proportional to the 6th power of the distance. So very low distance, when the distance is very low, or this distance, when distance is very low, then the energy attraction will be more, then more energy release, then stability of molecule will be more. So this is the London force, and combining this all force, dipole-dipole force, ion-dipole force, ion-induced dipole force, dipole-induced dipole, London force, combinedly called as van der Waals force. All these force called as van der Waals force. This is called van der Waals force, studied by van der Waal. Dutch scientist study this nature of force between the molecules of matter, studied by van der Waals. And this force is a weak force. This force is a weak force. Generally, force is generally on the basis of electron sharing. It may be on the basis of involvement of electron. The force is either ionic, the force is covalent, like this. But on the basis of the intermolecular force, on the basis of the nature of bonded atoms, without the involvement of valence electron, the nature of force may be dipole-dipole force. Here in all these cases, there is no involvement of valence electron. Only attraction exists between the different types of atoms and molecules. So on the basis of nature of molecule, it may be dipole-dipole, it may be ion-dipole, it may be ion-induced dipole, it may be dipole-induced dipole, or London force. And this force is a very weak force. London force is comparatively very weak force. And these combined, we can say these are called van der Waals force, studied by van der Waals. And van der Waals force, it is also a very weak force. All these cases is a weak force, it is not a strong force. This van der Waals force depends upon what? First one is size of the molecule. If size of molecule is larger, then van der Waals force will be greater. So van der Waals force is directly proportional to size. If size is greater, then van der Waals force will be greater. For example, I2 is solid, but your Br2 is liquid, and Cl2, F2 all are gas. Why? What is the cause? Why I2 is solid? Because large size. Why bromine will just again decrease? Because force is decreased due to small size. Why again force is decreased? Because all are in gas state due to again smaller size. That's why due to decreasing size, the van der Waals force decreases. That's why the physical state changes to solid, liquid and gas. So size of the molecule also very important. Size of molecules also that depends. If you branch molecule, that if suppose N-butane and another is suppose 2-methyl propane. Both are same. Here structure is straight chain. Already we have read this thing. This is a straight chain compound. But 2-methyl propane is a branch chain. If you see this straight chain molecule is, what happens? Molecule is like this. That means straight chain size is greater, but this molecule size will be spherical. Small size, you can see the small size, it is larger size. Straight chain form means larger size and branch chain means smaller size. That also affect van der Waals force. When size is more, van der Waals force is more. That's why a polymeric compound, polymeric chain, almost all are in solid form. Almost all polymeric compounds are in solid state due to long chain. If long chain is longer, then the size will be greater. Then what happens? The van der Waals force will be greater. That's why physical state also changes. So van der Waals force is very important. That is another thing, another example I will tell you that van der Waals force exists. Suppose why benzene is liquid. Benzene is liquid. Because benzene molecule you see it is a cyclic chain, carbon chain. C6H6, large size. Due to greater size, large size, the van der Waals force is greater. That's why benzene exists in liquid state. So this force may exist when the atoms and molecules will come closer. With a particular minimum distance, then attraction starts. The attraction may be dipole-dipole interaction. When they will come closer, then this weak force starts. Maybe ion-dipoles, maybe ion-induced dipole, maybe a dipole-induced dipole, maybe a London force between the non-polar molecules. Dry ice is called solid carbon dioxide, solid CO2. How CO2 exists? CO2 is a gas, but how it exists in solid state? When it is come closer, then when the pressure is more, then temperature will be decreased. Then CO2 molecule, although it is non-polar, but due to formation of polarity, when they will come closer, then one atom electron cloud attracted by other atom. The electron cloud of this atom attracted by the other. Because atom has a nucleus and electron, so due to difference in position of electron, the electron cloud gets polarized. Here electron cloud is polarized by the other atom. So due to this polarization, a polarity is developed, partially positive, negative charge developed, then the attraction starts. So due to this difference in nature of molecule, different types of intermolecular force exist. And it has been observed that this London force, or you can say this dipole-dipole force, that this London force or van der Waals force, we can say, is very weak force, and this amount of energy release, attraction energy of the molecule is directly proportional to the, or inversely proportional to the 6th power of distance. If distance is very low, when distance is very low, then attraction starts, then energy release. So everything depends upon the nature of molecule, nature of atoms. So these are the some types of intermolecular force. On that basis, we can study the characteristic, the physical properties of the matter. The physical properties of matter also depends upon intermolecular force. Why glycerin is viscous, but water is more mobile, free. Water molecule is more free, more mobile than glycerin, because glycerin molecule is large size molecule, attraction is greater. That's why we know liquid flow, the layer in the form of different layers. One layer attracts another layer due to the intermolecular attraction. That's why glycerin is more viscous than water. So like this, different types of intermolecular force exist. On the basis of intermolecular force, the nature of substance also varies. So this is about you practice more regarding some important concepts. What are the basic things of this, the types of intermolecular force, and practice more. Okay, thank you.